Is the blue lights on? Can you turn it on?
Oh, it's on. It's flashing.
Yeah, great. Okay. Alright, so I just have to show you girls two examples. Yep, two examples from the last exercise. Okay? And then there's an exam question that I really want to show you girls. Alright? Now, let's have a look at example 18a. There's nothing new with this, it's just application of it, alright? So a company produces 1 kilogram packet of sugar. Alright? A quality control check found that the weights of the packets was normally distributed with a mean weight of 0.995, standard deviation of 0.03. The company policy is to reject any packet with a weight outside 2 standard deviations from the mean. So like I said, if you have a normal distribution question, the first thing you do, even if you have no idea what to do, is just draw, you don't have to actually draw the curve, draw the score, z-scores out. Alright, so let's label it. So what goes in the middle as a recap? What's the mean? Yep. And it's obviously going up by the standard deviation of 0.03. So if I keep adding that on, I'm going to get these numbers. Okay? 1.05. And this side you've got 965. Can you guys see that from the back? Is that all right, Hafsa? Okay. So once you've set that up, girls, always label the percentage numbers. Helps a lot. So do you girls remember what that portion was?
34.
Yep, 34.
13.5.
13.5, very good.
And then 2 point.
And then next one is 2.35.
And then 0.
Yeah. You usually don't need the very last one. Okay, I've set it up. Let's answer the question. Now, okay. What is the smallest weight allowed by the company? Given in the question, the company policy in the last sentence of the paragraph is to reject any packet with a weight outside 2 standard deviations from the mean. So that means from the mean, 1, 2. So this is like 1, 2. These weights are the only ones that will be taken. Does that make sense? So that means the smallest weight allowed by the company would be that part, 0.935. Does that make sense? That's all it is. So like I said, if you set it up, it's not hard. What is the largest weight allowed? That one, 1.055. What percentage of the packets will be rejected? So maybe we did need this part as well, which is, okay. What part of it will be rejected? Those two ends. So 2.35 plus 0.15 times by 2, because obviously on that side as well. Okay. Which is 5%. Yep. All right. And last one. What percentage of large packets will be rejected? That would just be that portion. Yep. So that's III, that's IV. Okay, so that portion there. All right, so that's your basic question. Now let's have a look at a bit more difficult question. Okay, so part B, once again, even before I read the question, I know it's got to do with normal distribution, so I'm going to set the z-scores up first. Oh, my line isn't straight, but that's okay. So what is it? A mean shelf life of a spice is 13.4. So 1, 2, 3, and it goes up by 1.8 because that's a standard deviation. So I've got 15.2, 17, 18.8, 1, 2, 3, 11.6. Okay, girls, I've set it up. Now let's have a look at the question, girls. Would a shelf life, girls, look at the question. Would the shelf life of 20 weeks of a certain spice be unusual and why? If you have a look at all the z-scores here, obviously 20 is not there. Why would having 20 be unusual? Because it's out of the normal distribution. It's completely out of the range. It's got a very significantly high shelf life, right? So I think that's what they basically said. Yeah, so a shelf life of 20 weeks is outside of the normal distribution range. So that's why it's unusual. Yep? Alright, so that's first part done. Girls, second part. Second part. Find the z-score of shelf life for 15.5 weeks. We learned how to calculate the z-score. What do we use? The formula. Yeah? What? Do you remember what was next? Yeah. Yeah, so they want the z-score for which one, sorry? 15.5, take away the mean, divided by the standard deviation, you're going to get 1.17. Okay? So, the reason why they asked you that, the next question is what I really wanted to explain. Have a look at the next part. What percentage of shelf lives would be expected to, between 13.4 and 15.5? That's the problem right there. There is, none of these numbers are 15.5. And 15.5, let's say it's like here. So, you know how that's 34% and that's 13.5%. The question that I wanted to address from here is, how do you find the percentage if it's like in between a z-score and not on the actual one of the z-scores? Okay, how do you do it? Here's how you do it. So basically, now, girls, what z-score does the mean have? 0. And we just figured out the z-score 15.5 has? Yeah, so what you need to do is you have to go back to the table and basically find this. That's what you need to find in order to find the percentage. You have to go back to the table you used. Alright, so if you use the table and locate these numbers, what you'll find is that number is 0. Actually, what is that? What would the...
0.5.
That would be 0.5. Yeah, remember? That's the median. Now, this specific number is 0.879. So in order to get the percentage, girls, obviously get the big number first. You take it away, you get 0.379. What that means, the percentage of... What's the question? The percentage of shelf lives that will be between 13.4 and that is 37.9%. That's how you get it. And as you can see, it's very close. It's just a bit more than 34%. Yeah, does that make sense? Yep. So if the percentage number is not given, use a table.